Hello everybody, welcome back. This is going to be a new series of videos called From Python to Rust. In this series of videos we are going to explore a young and very exciting programming language, Rust. We will see how Rust can help us to speed up some of our existing and future Python code. Many agree that the key features of Python are its simplicity and readability, and portability of course. Let's try and see if we can have the same or similar simplicity and readability from Rust, and get that incredible execution speed of a compiled language. So here's the Rust website. Okay. So while Python is an amazing general purpose language, and it is super easy to write and understand, it might be too slow when we need to write an algorithm that needs to crunch through a lot of data. Of course, well-written Python code that uses something like NumPy or Cython is still very, very fast, and probably is enough for the most cases. But still, all of the checks that interpreted language like Python does when it runs the code will slow our code a lot. We will look at Python and Rust code side by side and attempt to port or rewrite some of our bioinformatics related code from Python to Rust while comparing the code execution speed of both. We will see that we don't necessarily need or have to sacrifice simplicity of Python for Rust's speed. And some of our functionality written in Python will stay in Python and just call our faster code rewritten in Rust. This way we are going to attempt to get a sweet spot, best from both languages, to solve our bioinformatics problems. Of course, like any book or course comes with prerequisites, so some of them are good Python knowledge. I would assume that if you're on my channel, you watched the DNA Toolkit series and you have very good Python foundation. Basic Rust understanding? I assume you are here because you know what you're doing, right? You understand the difference between compiled and interpreted language, you understand the difference between statically and dynamically typed language, and you have a code editor that already runs Python, and you can add Rust integration into that too. And good to have is previous C-style, C-type language experience, and desire to learn a new, exciting, compiled and fast systems programming language. So if we take a look at the Rust website, this probably is one of the friendliest websites for programming language. If you don't have Rust installed, you can just go to install section here and have very beautiful instructions for all the operating systems here. And the other thing is Rust community, and this is an official community in Matrix, is just amazing. If you're one of those people who are trying to learn Rust to speed up some of their code that is written in other slower languages, this community is just really, really good, and it is an official Rust community. You can always click here and see all the other Rust-related rooms they have here. Okay, they have like German rooms here, French, they have Finnish, they have for complete beginners, embedded stuff, they'll probably use some web stuff too. This community helped me a lot to learn Rust, and of course I still am learning it. Okay, so let's go to the code editor. Here it is. We're going to set up a folder where we're going to have Python and Rust at the same time, and we're going to execute both. Okay, so let's set up our work folder where we're going to have Rust and Python code and see them side by side. So if Python is as easy as just creating a Py file from any folder and running it, then Rust is a bit more complicated, but not a whole lot. Okay, so what we're going to do, I'm going to create a folder. So I'm opening a terminal, but you can do that in your file explorer. I'm going to navigate where all of my files are. They're in media, work, and I'm on Linux. Okay, but again, this doesn't really change for Windows or Mac. You can create a folder in, let's do that in bioinformatics because it is bioinformatics related. And now I'm going to create this work folder for us. I'm going to call this PyRust. I'm going to cd into this. Okay, so the first projects folder is going to be Python code, and the other one is going to be Rust. For Python, we created a folder and we create a file and just run it from there. For Rust, we're not going to do that. We're going to use Cargo to create a Rust project. This is the proper way. If you're going to go back to Rust website and go through introduction tutorials, they're going to show you how to do that. So cargo, and that's actually a good way to see if Rust is installed in your system. So if we're going to just run cargo, it will say, okay, you passed cargo with no parameters, and we're going to pass a new parameter, okay, to that to create a project for us. So we're going to clear it again. We're going to do cargo new project, and the name of the folder, it is going to be called just Rust, so we can easily differentiate between Rust and Python folders. And I'm going to pass this parameter. This will make sure that it's a binary project, not a library project. Okay. So now if we're going to go and ls, we see these two folders. So now let's bring these two folders into our project. Okay, so open folder, and it's in work, Bioinformatics for me, and Rust. Okay. So here it is. The folder we called py_rust is here, and it has Python and Rust. We're going to see a small problem right away. So if we look at the structure of the Rust project here and open this hello world file that has been generated for us, let's try running it. I'm using this code runner extension, but we're going to get back to that in a sec. If I'm going to run this, basically what we see, it is complaining about the folder project structure. Again, it's not as easy as Python, where you can create a file anywhere and just run it. Rust is very kind of strict about that, where it's looking for the files. So instead of importing the whole folder that is rust_py that has Python and Rust projects in it, we are going to do this. We're going to do add folders to workspace. And we're going to add these folders one by one. Okay, so we're going to add Python first. And of course, let's get rid of this folder here. So we have Python. And let's add another folder, which is our Rust project. Okay, so let's see if this will work now. We're going to go to source and let's run it again. All right, so we can see that this works. We see the hello world. Let's go to our Python and create a new file so we can run the same thing. We're going to call it same way as the Rust one is called, main.py, main.rs. Okay, let's do our first print. Hello, I am Python. Okay, so let's run it. Hello, I am Python. Let's run hello, but modify the string here. I am Rust and I am fast. Okay. Okay, it works. That's great. So that's the beauty of fully configured code editor. You can switch to any language you want here. Let's say C++, Java, you can have multiple tabs opened, Control-Alt-N, and code runner will just execute your code. So if for Python, when you install the code runner extension, which is this extension, we've discussed that in our development tools setup video. I'm going to link to that right now too if you have not seen that. So code runner just lets you use Control-Alt-N to execute your code. So for Python and some other languages, it just works out of the box. So that's why we have this. We just Control-Alt-N and it runs it. And for Rust, it's the same. But for Rust, you have to modify the execution command here. Okay, it won't work out of the box. It won't understand the folder structure. We've seen it was complaining before when we were running the same main.rs, main source code file, from a subfolder. So, okay, so I'm going to post the configuration in the description below. So in your VS Code, you can tap F1 and you can type open settings. Okay, so open settings in JSON. Let me make this smaller and this smaller too. There's this part. It's quite big. It's called code-runner.executorMap. It's large because it has all of these languages. Actually, I could just get rid of most of these. But that's the important part here, Rust. I'm going to copy and paste this again into the description so you can add that to your code execution map, and you will be able to execute your Rust code with the same command as Python or any other language. Okay? So after you've made sure that you have these two extensions installed, and you've used the configuration part for your code runner, so you can run your Rust code the same way you run your Python code with the key combination, you are ready to work. Okay, so what we're going to do, as we discussed before, we're going to run these pieces of code side by side. And let's get rid of all of the unneeded stuff. Here we are. So we can see right away, they're very similar. If Python doesn't really need the main Python function, an entry function, then Rust, like C++ or Java, they actually need that. So if you run Rust, you can see it shows quite a bit more code here. That's the debug information. We don't actually need that, and we're going to get rid of that, so it's very close to Python. It's just the stuff that we're working on is printed out, nothing else. We will discuss unoptimized and debug and release builds in the future, but it is irrelevant at this moment, okay? So what we can do, we can go back to our F1, open settings, and scroll down where we run our Rust. And let's add this parameter, which is -q. That means quiet. So cargo, run our project, but be quiet. Don't print out extra information. And we're going to add this here too. Let me save this, close it off. Let's try running Rust again. And we can see it's nice and a clean line, nothing else. The same as Python. Let's switch to Python, run it, switch back to Rust and run it. That's great. Okay, now we are ready to start writing some code and basically comparing two languages. So we have our first print working, and we can see the similarities between them right away. So let's try working with some variables, right? So if we're going to do x equals 100, for example, and y is equals to 1.0. So now let's use our print statement to see how we can print these variables. Of course, you know how to use f strings. So x is this, and this x, and y is this. Let's try running this. Okay, so now we're going to try replicating the same functionality in Rust, and we have to be in one of our functions. We just have one main function, so we have to get into that first and declare our two variables. Okay, here we are, and let's try printing this out. So formatting here is a bit different, so x and y, like that. It's similar to Python's formatting strings. So there's f string, and there's a way to format the string if you're not using an f string. So we're going to do this x and y, and of course semicolon. Let's see if it does the same thing. Okay, so again, this is Rust, this is Python, and this is Rust again. You can see the Python file here and the Rust icon here. So we will be switching between them, and you know which one it is by, hey, I'm Rust, hey, I'm Python message on the screen, right? Okay, so let's try to do something else here. So what if we want to modify y here? Y is equals, let's say y multiplied by -0, let's do pi. And let's print this out again. Okay, let's print it out. We can see it works. Okay, so let's do the same thing in our Rust. We can actually copy this here. And semicolon, of course. And let's try printing this out. We can see right away that there's something wrong. Let's try pointing at this. And it says cannot assign twice to immutable variable. At this stage, you will have to know what mutable and immutable means. So immutable variable is something you declare here once and you cannot change it throughout the code, and mutable one is the one you can change. So here in Python it's so easy, we just specify x and y and we can change it throughout the program, but here we have to make sure if we want to change it in our program we have to specify a mute keyword. So we specify that here and the problem goes away. Let's try printing this out. Here we go. So here it is. So it's the same code. Let's try running Python again. Yep, exactly the same. So how about we look at some if statements? So we know that if, for example, y is less than x, and let's use a print, of course, and use our f strings. The is the difference between x and y is, and we can do this. Let's say, let's do x minus y, and let's try running this. So let's now try to replicate the same functionality in Rust. You will see that if statements are very similar. F y is less than x, but we have to use these curly braces, and we're going to use this print statement, of course, to print out the same message. We're going to copy it, we're going to move it here, and let's use this string we already have in Python. Okay, so this, and of course we can't do that, we need to do this formatting here. And we did x minus y. And let's try running this without even looking at this, okay? We can see that there is some complaints here. So now when we run it, we can see that it is complaining about the different types. So y is a float because it has 1.0, and the x is 100, which is an integer. This is a statically typed language, and I'm going to link to a description about the difference of statically and dynamically typed languages if you're not sure what they are, but I would assume if you're here, you do know what they are. So let's go 100.0, that's the easiest way to make it a float, and try running it again. And now we can see that we get the same result as pi. Let's go back to the Python, run it, back to Rust, and run it. Okay, now that our regular if works, let's try adding some branching, okay? So we have if, else if, and else. So Rust is going to be very similar to Java and C++. It's using this else if and else full keywords instead of the concatenated elif in Python. So this is how branching works in Rust. It's very similar, as you can see. So let's try running the Rust version. Here it is. Okay, so here's the example of if branching in both languages. So you can see they are very, very similar. So now let's take a look at two more things. Loops. Let's write a while and a for loop in both languages. So let's declare x equals to 5 and write our while loop. While x is larger than a 0, not 9, but a 0. Let's print x, and let's actually do this. So x is, and we're going to do this. And of course we need to make sure that x changes, so it's not an infinite loop. X minus equals 1. Okay, here it is. X is 5, 4, 3, 2, 1. Okay, so now let's try replicating the same while loop in Rust. So as we mentioned before, we cannot really overwrite x the same way we do it in Python because it's a statically typed language. It's set here that x will never change and it is equals to 100. Here we say y is equals to 1.0, but it might be changing while the program runs. So there is something called variable shadowing in Rust, so we need to actually redeclare it if we want to use it. So let's declare it as a mutable. Let mute x equals 5. And I just love the way Rust tells you these things, okay? So variable does not need to be mutable. It kind of says, okay, you declare this as a mutable, you want this variable to change, but you're not really changing anywhere. Are you sure it needs to be mutable? It's just great, isn't it? So, but Rust doesn't know that we're going to write a while loop here that modifies that x. So x larger than a 0. And now we can see that it will go away as soon as we start modifying the x. So let's do the same print. We're going to copy this from our Python. I'm going to use Rust's print. Okay, so instead of this, we're going to do this x. Okay, of course it's not an f string. And now as soon as we modify x on the line 21, we're going to see this warning go away. And luckily enough, Python and C style languages have this x minus equals 1. So we don't have to type the whole thing x equals x minus 1. So they are exactly the same. And now we can see that it's gone. Let's try running it. So we can see that our loop works exactly the same as in Python. So let's go back to Python, run it, Python, Rust, perfect. Okay, so let's write a for loop now in both. So for I and range, we're going to use a range. And we're going to specify range, let's say from 3 to 7. And we want to print. And we're going to use our trusty f string, of course. I is in this. Okay, let's try running this. Of course, you know that these for loops work. We can maybe comment this out. We can see that E is 3, 4, 5, 6. 3, 4, 5, 6. Okay, so now let's take a look at Rust's version of for loop. It's going to be a little bit different. So we're going to do for I in, and we have to specify range this way. We don't use a range function, double dot, and 7. And of course we need to do this, and we're going to print. We can take a look at what it says to us. It says, oh, unused variable. Yeah, we're going to use that now in our function. Let's actually copy this f string as we did before. So print, and it's not an f string, and we're going to move our I to here. And of course, semicolon. Okay, it works, and let's comment our while loop as well while we run our for loops. Okay, so E is 3, 4, 5, 6. What you can do in Rust on top of that, you can specify a range. So let's do this. Let num range is equals to the same thing, 3, 7. And now we can use this num range. It's complaining that it's unused. Are you sure you need unused variables? They take space. Make sure you use all of the stuff you declare. So now we just modified it. Instead of specifying the range here, we specified it to there. So we run it for a test. We can see it does the same thing. That's great. Okay, so these for loops are looping through some range of numbers. How about we loop through a list? So let's declare in Python first. We're going to do tmp lst, temporary list. We can have DNA, RNA, and mRNA in this. And of course, let's put in quotes. And don't forget commas. Okay, here we are. Let's write a for loop for I in tmp list. Of course, we know how this goes. So now let's add our print statements. Okay, so we're going to do fstring. And we're going to say I is, and we are going to do this, I. Let's run it. And of course, it's going to print out the DNA, RNA, and mRNA. It's going through this list, as we know. Okay, so now Python version works. Let's implement the same in Rust. So Rust doesn't have lists. Instead, it has vectors. It has the same functionality, more or less. So we need to declare tmp vec, not a list. And it's equals to vec. And we can copy this from Python here. And we're going to see a problem because Rust likes double quotes, just like a C-style language. Okay. I'm going to change that here too. And semicolon. Now we have our vector declared. And of course, it's complaining that we declared some stuff. We used up memory, but we never used that. Okay, let's run our for loop for I in tmp vector. It will be exactly the same as in Python, by the way. And we're going to do print ln. And let's copy this, but not the whole f string. Here we are. And we're going to do this. And of course, semicolon. Let's run it. Now we can see it does the same as Python. Let's go back to Python, run it, Python, Rust. Okay, that's great. So now what if we want to return an index and print both, an index and what is in that index? So we have DNA at index 0, at index 1 is RNA, and index 2 is mRNA. So at Python we do this, we use enumerate list. And now it's going to return two things. It's going to return position and let's say a value. So we know what it is returning. And now let's change our print statement to reflect that position and a value. Let's say value at pause is value. Okay, so let's try running this. So it says value at position 0 is DNA, RNA, mRNA 0, 1, 2. So now we can see it works in Python. How can we do the same thing in Rust? Even though these two for loops look almost identical, Rust is quite different from Python. Rust has this ownership and borrowing model. This is a self-study part. We're not going to go in depth and kind of discuss what it is, but we're going to take a look at the example. So if we, in Python, for example, do this for loop and we still want to, let's print this as an example. Print tmp list. Let's print the first index, or the zeros one. It's going to print DNA, because of course the zeros position is DNA. Let's try doing the same in Rust. Okay. tmp vec, 0 position. Let's try running this. Okay, it is not going to work. It says value borrowed here after move. So what happened here? We have created this vector with these three values, and then we run this for loop, and we give this temporary vector to this for loop to do some operations on. In this case, it's just printing out some values that this vector has. But what we actually did under the hood is we gave ownership. We said, okay, tmp vec, this for loop now owns you. Okay, so for loop worked on these values, DNA, RNA, mRNA, by printing them out on the line 31 and discarded them. That's why we cannot really access this vector after we gave the ownership to this for loop. So for loop starts with this bracket and it ends with this. So as soon as it ends, everything that was in this for loop is discarded. Okay? So how can we fix that? We need to do this. We should ask our vector to return an iterator instead of the ownership. So if we do this, we can save this and let's try running it again. We can see that error is not popping out and we have exactly the same result as in Python. Now that we understand why this is happening, the borrowing and ownership model is very interesting stuff. You should definitely read about that. I'm going to link that in description below. So now we need to go back to our enumerate. Now we run into another problem. You can see that it's not auto-completing this function for me. That's another thing about Rust tools. Rust is quite young language, and I was talking to people on that chat I've showed you before, and they said that RLS, this part here, we can see it's running in the background. RLS, it's Rust language support, is still kind of maturing. So even though I'm running the latest version, it doesn't always work correctly. So hopefully this is going to be improved in the future versions, but let's try completing that ourselves. Enumerate. So now we can see that enumerate method is correct. Let's see what it complains about at this I variable. It says, help, the trait display is not implemented for a string, because now it returns the same as in Python. It returns an integer, which is a position, an index, and it returns a value that is stored. So what we need to do this pause value to replicate what Python has. Let's actually do the same kind of string we did here. Okay. Of course, we need to get rid of this. And now let's do this. Position and the value. And now another thing we need to do, we need to make sure it's in these brackets as well, because it's a tuple that is being returned. So let's run it. And now we can see it works. Okay, so position 0, DNA, RNA, and we're gonna run Python version again. We can see it's Python, this code, go back to Rust, Control-Alt-N, it's Rust, we can say it's Rust, and it's the same code. Okay, so this is it for this video. I hope it was very interesting to see two languages side by side. I think it's a very good way to learn a new language. If you know one language quite good, you can kind of open another tab like that and can rewrite your existing functions in that new language. So that is what we're going to be doing in this series of videos. Okay, before we close today, let's take a quick look at the execution speed of both languages. And mind you, that definitely is not the best way of kind of measuring performance, but we can at least see how fast is our code interpreted by Python and how fast our code is run from a binary that has been compiled by Rust. So that's the difference between interpreted and compiled languages. I'm going to do this. I'm going to open a terminal. Let's see where we are. We are in a Rust project. So instead of running like cargo run, that will just run our code. It will compile it and it will run it. Okay, we're gonna run the executables. So again, let's see what we have. We have this target. Then we have a debug, because we are running a debug version of it. We're not gonna get into that today as well. If you're not sure what a debug and release builds are, we're gonna discuss that in our future videos. So I'm gonna go to debug. And our project is called Rust, and we can see that there is an executable file called Rust. And of course in Linux, you don't have extension like exe in Windows. So what we can do, we can try running it. And here's our app. You can actually distribute this app because it's an executable. It doesn't need an interpreter. I can give you that if you're running Linux, just a file, it should run just fine on your machine. Okay, so now instead of just running it, let's use a Linux built-in command, time. It might be built into Mac as well, I'm not sure. So let's do Rust, and we can see it took 0.03 seconds. Let's try running again, 0.01 second. So it depends on what is running in the background on your machine at this stage. So from 0.1 to 0.4, let's say. So now we can see that it's really fast. Let's try comparing this to Python interpreter. So we're gonna time that too. We're gonna run our Python, and we're gonna navigate to our Python folder. So let's see where we are. Okay. It's not here. One folder back. Here it is, our Python. And of course, our code is called main.py, the code file. Let's try running it. Okay, we can see it's quite a bit slower, and I would say a lot slower. Of course, we are running the interpreted code here. It's being interpreted as every single line is being executed. There's a lot of checks happening, while in our Rust side, if we're gonna run Rust again quickly, so we can compare these two, okay? 54 to 002. And on Rust side, of course, all of the checks have been done by the compiler when it was creating this final binary executable. And it probably did some optimizations, even though this is a debug build, where the optimizations are not really applied to your code. So we can create a release build, and it will definitely apply quite a lot of different optimizations to make our code even faster. Alright, so this is it for today. I really hope you enjoyed this video where we were writing Python code and transferring that into Rust. I think definitely it's the best way to learn a new language if you know some other language already. Basically rewrite the same functionality in this new language you're learning. We will be rewriting some of our DNA toolkit and our next upcoming genomics toolkit in Rust. So we're going to be implementing stuff in Python first. We're going to take a look at the execution speed of our Python code, and if it's necessary, we're going to rewrite that in Rust. I'm planning in this particular series to cover all of the Rust basics side by side with Python. So let me know what you think about that, and until next time, Rebel Coder signing out.